Hi everyone, welcome to my Max Academy. In this video, we'll continue with the chapter Relations and Functions from your 12th standard CBSE Mathematics. I'll continue with example 17 in your textbook in page number 13. Page number 13, example 17 in your textbook. So what is given in that is, in example 17, f is a function from r minus 7 by 5 set. What is the meaning of r minus 7 by 5? All the real numbers except 7 by 5. Except the fraction 7 by 5 are all in this set, and the set r minus 3 by 5. R minus 3 by 5 means all the real numbers except 3 by 5, and g is a function from r minus 3 by 5 to r minus 7 by 5, and f of x is defined as 3x plus 4 by 5x minus 7, and g of x is defined as 7x plus 4 by 5x minus 3. And this set r minus 3 by 5 is called as A set, and r minus 7 by 5 set is called as B set. Right? So r minus 3 by 5 means all the real numbers except the real number 3 by 5. So this has all the elements except 3 by 5. This has all the real numbers except 1 by 5. Obviously, because here we cannot have 7 by 5, because 7 by 5, if I substitute here x as 7 by 5, you will get infinity. So the function f will not be defined at the point 7 by 5, so that is removed from the domain. So the domain is r minus 7 by 5, and similarly for g of x, you have to remove the number 3 by 5, because if I put 3 by 5 in the place of x, we will get 5 into 3 by 5, 5 will go, we will get 3 minus 3, which will make this function infinity. I mean, not a real number, not defined. So for the 0.3 by 5, the number is not defined, that's why we are excluding that from the real number. So now the function is properly defined. Right? Now, and we have to, and what is IA of x? IA of x means it's an identity function from set A to set A. What is the meaning of A? It is from set A to set. So your IA means IA is a function from A to A set, and IB is similarly from a function from B to B set, and I of B of x is defined as x. Like I of IB of x is x, IA of x is x. IA of x is x means what? Identity function. Right? We know that f of x is equal to x means it's an identity function. F of x is equal to x is an identity function. Now every element goes to itself. 1 is mapped to 1, 2 is mapped to 2, 3 is mapped to 3. Like f of 3 is 3, f of 4 is 4, f of 5 is 5 means it is called an identity function, right? Which you would have studied in your 11th standard. So now here we have to show that. So this is given. F is a function from this set to this set. F of x is defined. Similarly, g of x is defined, and IA of x is x for every x in A, and IB of x is x for every x in B. Now we should prove that f of g equal to IA. We have to prove that f of g, which means we have to prove that f of g of x is x. It is matching with IA means what? If I find the function f of g of x, that should be equal to x. Similarly, g of f of x is also x. If g of f of x becomes x, then it means it is equal to IB of x, which means it becomes. So we have to show that f of g is an identity function, and g of f is also an identity function. And what is this function? I of x equal to x. IA of x equal to x. Here IB of x equal. So this B denotes that it is from the set B to B. This denotes that the identity function is from set B to B, and identity function is always from the domain and codomain will be same for identity function. For identity function, always domain and codomain is same. So IB means it is from set B to B. I of x is x. I of x is x means identity function. That's why we are denoting by the letter I. Now what we have to prove? We have to prove f of g is IA and g of f is IB, which means you have to prove f of g of x is x and g of f of x is x. That's what you have to prove. If you prove that, then it becomes identity function. Fine. Now how do you prove this? A solution. The solution is, let's find what is f of g of. So f of g, first of all, let's say this function, it's a function from which set to which set. We need to find this function. We have to find the function f of g, and we have to prove that f of g is equal to I of a. For that, let's try to understand this f of g is from which set to which set. Right? Now here, so this is called as B. So f is a function from B to A, and this set is A, and g is a function from A to B. Right? So this set is A, and this set is B. So f is a function from B to A, and g is a function from A to B. So f of g will be a function from where? You have to see the domain. This is what is the start. What is the domain of the G? Domain of G is what? A. To what is the codomain of F? Codomain of F is this A. So it's a function from A to A. F of G is a function from A to A. Right? So G is from A to B and F is from B to A. So your F of G will be from A to A set to A set. Right? Now we have defined the from which set to which set is done, which is same as I of A. I of A is also from A to A. And we are going to show that both are equal functions. So F of G is from A to A. Now what is F of G of X? Let's try to find that is equal to F of, we have to find the function. F of G of X. F of G of X, that is equal to F of, what is G of X? G of X is this. F of, in the place of G of X, I got to put 7x plus 4 by 5x minus 3. So instead of G of X, I am writing this because this entire value of G of X. G of X is this. So instead of G of X, I am putting this. So now it becomes F of this. Now what is F of this? That is equal to, what is F of this? I'll write it here. F of this is equal to, what is F of X? F of X is 3x plus 4 by 5x minus 7. So F of this means you think this as X. So F of X, so wherever X is there, here, I have to put this entire value. So which means it will become 3 into X. X is this. 7x plus 4 by 5x minus 3. That is 3x plus 4 by 5x. So 5 times x is 7x plus 4 by 5x minus 3. That is 5x minus 7. What is F of X? You think this as that. F of X is 3x plus 4 by 5x minus 7. That's how we write this, right? So that is equal to, now let's simplify this. So this becomes what? 3 into 7x plus 4 into 5x minus 3 by this one. 5x minus 3. I am adding these two by 1. Right? Then whole divided by 5 into this. 5 into 7x plus 4 minus 7 into this. 5x minus 3 whole divided by 5x minus 3. I'm doing fraction, subtraction or addition. Now 5x minus 3 will get cancelled. Now this will become, if you simplify, so that is equal to, so here what we have, on the left hand side we have this F of G. So F of G of X is equal to, now this one, 7 times 3 into 7x is 21x plus 3 4s are 12 plus 20x minus 12 whole divided by, multiplying this by 5 7s are 35x, then 7 times 4 is 20 minus 7 into 5 is minus 35x, then minus into minus is plus 21. Right, now if you see where plus 12 minus 12 will get cancelled, 35 and minus 35 gets cancelled, you get finally this is equal to 21 plus 20 is 41x by 20 plus 21 is 41, which is equal to x. So what do we have proved? We have proved F of G of X equal to X. So which means your F of G is what? So F of G of X is equal to what is X? X is your I of A. I of A of X. Instead of X, I can put I of A of X. Identity function, right? X. I of A of X is what? X. So which means we have got F of G of X is equal to IA of X. We can also put X is IB of X, but the function is from A to A. F of G is a function from A to A. So I have to put IA of X. X is what? IA of X. Now, which means F of G of X is equal to IA of X for every X belonging to A. For every X, because it's a function from A to A. For every X in this, the F of G of X is what? X, which is identity function. Whenever you get a function, suppose if G of X is equal to X, then G is called as identity function. If you got some other function H of X is equal to X, then H is called as identity function. So here you got F of G of X is equal to X, therefore F of G of X is called as identity function. And it is on the set A. So this IA denotes that A is, we will put it in the bottom like this. IA means it is from the set A to A. I is from A to A, this is also from A to A. So therefore both are equal. Both F of G is also from A to A, I is also from A to A. And F of G of X is also X, IA of x is also x, which means both are equal functions. These two are equal. Therefore, we can say f of g is equal to IA. So we can just remove this x and x. We are just talking about only the function now. Therefore, f of g, we are not cancelling, right? Generally, we are saying these two functions are equal because for every element in A, their images are matching. Therefore, f of g is equal to IA. So we have proved this part. Now we should prove g of f of, right? G of f. Now what is g of f? Second part. Proof for the second part. Yes. What is g of f? Now g of f is function from which set to which set? Now we have to see this set. Yeah, function f. F is from which set? F is from this set. B. So g of f is also will be from this set. B. 2. The codomain will be where? What is the codomain of g? G's codomain is this set, which is B. So the codomain of g of f also will be B. So your g of f is a function from B to B, right? Because your f is from B to A and your g is from A to B. And right here, see, your f is from B to A and your g is from A to B, means your g of f will be from B to B. G of f will be from B to B, right? So g of f means first f is applied. F is applied to this to B, right? So now, so this is from B to B. Then we have to find what is the definition of g of f of x. I told you, for any function, we have to first define from which set to which set it is going, then the definition of the function. So the set is defined. Now we have to go to the definition of g of f. What is g of f of x? That is g of f of x. What is g of f of x? G of f of x. So which means that is equal to g of, what is f of x? F of x is this 3x plus 4 by 5x minus 7. So 3x plus 4 by 5x minus 7. So instead of f of x, I am putting the f of x value. F of x value is 3x plus 4 by 5x minus 7. That I am putting here. 3x plus 4 by 5x minus 7. Now we have g of x. Now what is g of, this is like x. Now what is g of x? G of x is 7x plus 4 by 5x minus 3. So wherever x is there, if it is x here, I have to put x here. But here I have such a big expression. So wherever x is there, you have to put this here. So this will become 7 into x. X is this. So 7x plus 4. So plus 4 divided by 5x minus 3. So 5 times x. X is again 3x plus 4 by 5x minus 7 plus 4. Sorry, plus minus 3. Minus 3. So g of x is what? G of x is 7x plus 4 by 5x minus 3. So whatever is here, that will go to the x. Because you are finding g of this value. You have to treat this as x. Right? So then what do we get? We get 7 times 3x plus 4 plus 4 into this. Right? This into this plus this into this. I am doing normal fraction addition. 5x minus 7 by 5x minus 7 whole divided by this denominator, that is 5 into 3x plus 4 minus 3 into 5x minus 7 by 5x minus 7. So 3 means 3 by 1. This into this minus this into this by this into this. Now what do we get here? If you simplify this, so I will write it here. So you get 21x plus 28. 7 3s are right. These two will get cancelled anyway. Plus 20x minus 28 by 15x, then 5 4s are 20, then minus 15x, then plus 3 7s are 21. Now 28 is cancelled. Here 15x minus 15x is cancelled. So finally what we get? We get 21 plus 41x by 41. Again we got x. So what we have got now? We have got g of f of x is also x. G of f of x, finally we got it as x. So g of f of x is x. So g of f of x means, therefore g of f of x is equal to what? IB of x. Why x can be written as ib of x? Because ib of x is x. So instead of this x, I can put ib of x. And why we are putting b, not a? Because your g of f is a function from b to b. So both are identity function. But the set also matters. So here it is defined on set b, here it is defined on set a. So there are two different functions. These two are not same functions because the sets are different. Right? So ib, so g of f is also from b to b, ib is also from b to b, and the g of f of x is also x, and ib of x is also x. Therefore, these two, g of f of x is equal to ib of x. So therefore, we can say g of f equal to ib. G of f equal to ib, we will not write this x and x. Fine, so we have put this. Right? So we have put this here, and we have put this here. So that completes your example 17. So all of you can pause the video and take the notes. I'll go to the next problem, which is problem example 18. So example 18 is easy as well as important. So example 18, EG18 means example 18. So what is given in that example 18? So it is given that show that if f from a to b and g from b to c. So f is a function. So what is given is f is a function from a to b is 1 to 1. F and g are 1 to 1. So f is a function from a to b, comma, g is a function from b to c, are 1 to 1. Are 1 to 1 function. That is given. Then what we have to prove? Then we have to prove that TP. To prove, TP means to prove. We have to prove g of f function from a to c is also 1 to 1. Is 1 to 1. So f is a function from a to b set, and g is a function from b to c, are 1 to 1 functions. They are 1 to 1 functions. Then we should prove that the composition of the function g of f, which is from a to c, obviously if f is from a to b, g is from b to c, means your g of f will be from a to c is 1 to 1. We have to prove that g of f is 1 to 1. But f and g are 1 to 1 is given in the question. Right? And we have to prove g of f is 1 to 1. Now how do we prove g of f is 1 to 1? So to prove any function that is 1 to 1, how do we start? We will take two elements from the domain A. So let x1 comma x2 belongs to A such that they have the same image. We will take two elements from the domain such that g of f of x1 equal to g of f of x2. Right? So how do we generally prove? In the previous videos, if you watch how we proved that f is 1 to 1, we will take two elements x1 comma x2 from the set A domain such that their images are same under this function g of f of x1 equal to g of f of x2, which means their images are same. Then we should finally prove that x1 equal to x2. Then the elements that we took from A, they are not different elements, they are one and the same. That makes it the function as 1 to 1. So this is there. Finally we have to prove x1 equal to x2. We have to prove x1 equal to x2. Now, so g of f of x1 means what? As per the definition, g of f of x1 equal to g of f of x2. That is the meaning of g of f of x1 means g of f of x1 is g of f. Now, g is a 1 to 1 function. G is a 1 to 1 function that is given. So whenever a function is 1 to 1, suppose g is 1 to 1, then g of x1 equal to g of x2 means you can immediately say this implies x1 equal to x2. When if g is 1 to 1. If g is a 1 to 1 function, and whenever we see g of x1 equal to g of x2, then we can immediately say x1 is equal to x2. That we can say when here g is 1 to 1. Now here g is 1 to 1, and we have something like g of this you treat it as x1. G of x1 equal to g of x2. It looks like this. Right? If g is 1 to 1 and g of x1 equal to g of x2, then we can say that x1 equal to x2. Which means Here g of, you treat this whole thing as your x1, this whole thing is your x2. So g of x1 equal to g of x2 means, and if g is 1 to 1, therefore we can say this implies x1 equal to x2. I say x1, I write f of x1 because this is your x1. You compare this with this. In the place of x1, you have f of x1. In the place of x2, you have f of x2. So I have to say x1 equal to x2, which means f of x1 equal to f of x2. Because the reason is g is 1 to 1. Because, and this means because g is 1 to 1 function. Because g is 1 to 1, we can say that. Fine? Fine. So since g is 1 to 1, we can say that whenever g of x1 equal to g of x2, I can say x1 equal to x2. So the value inside this will be equal. Whenever the function values are equal, the actual elements are equal. This implies f of x1 equal to f of x2 because g is 1 to 1 because of this reason. Right? Which I had explained this in detail in the previous videos. The previous videos where we did exercise 1.2 and all that. Now again, f of x1 equal to f of x2. Now again, f of x equal to f of x, and f is 1 to 1. So when f is 1 to 1 and f of x1 equal to f of x2 means, again if f is 1 to 1 and f of x1 equal to f of x2 means, I can say x1 equal to x2. So therefore this implies x1 equal to x2. Why x1 equal to x2? Because f is 1 to 1. When f is 1 to 1 and f of x1 equal to f of x2 means, I can say x1 equal to x2. We need not prove x1 equal to x2 here from here to here because f is 1 to 1, that is given. F and g both are 1 to 1. Therefore, when f of x1 equal to f of x2, then we can say x1 equal to x2. When we can say that? Because, again the reason is because f is 1 to 1. F is 1 to 1 and if the images are same, then we can say the pre-images are also same. x1 and x2 are pre-images. F of x1 f of x2 are called as image of x1 and x2. So, x1 equal. So now how we started? We started with g of f of x1 equal to g of f of x2 and we finally proved x1 equal to x2. So whenever we prove that g of f of x1 equal to g of f of x2, starting with this, and if we get x1 equal to x2, this means, this implies g of f is 1 to 1. It is a 1 to 1 function. So that's how we prove that it's a 1 to 1. How do we prove 1 to 1? We'll take two elements from the domain such that their images are same, such that they have same image. Then we have to prove that the elements itself are same, x1 equal to x2. The two elements that we took from A, they are not different, they are one and the same. Right? If we get x1 is not equal to x2, then it will become not 1 to 1, which means the images are same, but the elements are different. If x1 is not equal to x2, which means two different elements, their images are same. F of x, g of f of x1, g of f of x2 means image of x1 is g of f of x, image of x2 is g of f of x2. So if we get x1 is not equal to x2, which means two different elements have the same image. When two elements have the same image, when two elements go to the same image, it becomes many to one function. It's not a 1 to 1 function, right? That we get when x1 is not equal to x2, but here we got x1 equal to x2. Therefore, this implies g of f is 1 to 1. So we proved that g of f function is 1 to 1. Whenever f and g are 1 to 1, we have proved g of f is 1 to 1. That's a proof. Clear? Now let's go to the next problem. I will erase this one and I'll write that here. So that is, we have our example 19. EG 19 means example 19 in page number 13. It says, show that if f is a function from A to B, g is a function from B to C are onto, then g of f from A to C is onto. So this is the onto case. So what is given? Given is f is a function from A to B, comma g is a function from B to C, are onto function. Both are onto are onto functions. So f is onto function, g is onto function. That is given. So what we have to prove? To prove is the function g of f, which is from, obviously g of f will be from A to C. A to C is onto. That is what we have to prove. We have to prove that this function is an onto function. So what we have to prove? So to prove is g of f is onto. Given is f and g are onto. What we have to prove? G of f is onto. Right? So now how do we prove that g of f is onto? Now again, let's take the problem. Now solution. Right? Now we have to prove that g of f is onto. Now how do we prove that a function is onto? To prove a function is onto, we will take always an element from the codomain, and then we should show that there is an element x in that domain such that f of x is equal to the element that we took from this set. Suppose if I take an element some z from this set, then I should be able to find a x in this set such that f of this function, the value of this function g of f of x should be equal to z. Then it becomes onto. So any element that I choose from C, if I am able to find an element in A set such that if this g of f is on that operated on that element x, this means g of f of x should be equal to z, where z is the element that I took from the set C. Then it makes that function g of f as onto. Right? So how do we prove onto? We'll say let z be or z belongs to B, z belongs to C be any element. Z belongs to C. So I am taking an element Z from the set C. Be any element. Z belongs to C. Be any element. Right? Now, be any element. Since the function G is onto function. See, we took an element Z from this set C, which means that the element is in this set C. When I take an element from this C, means it is same as this C. Now, to prove that this is onto, we will take an element from here, then we will go here. So that element is in this set C, but G is onto. G is an onto function. So then, if G is an onto function, then any element that you take from here, you will be able to find another element in this set. You call that as Y, such that G of Y will be equal to Z. See, for every Z, every element that we take from this set, we will be able to find another element here, such that G of this element will be equal to the element that we took from C. Right? That is the definition of onto, and it is given G is onto. F and G are onto is given. So which means since G is onto function, so therefore since onto function there exists an element here in this set B. There exists Y belonging to the set B such that G of Y will be equal to the Z. Because since G is onto function, there exists a Y. I am calling the element that I am taking from B as Y, such that G of Y will be equal to Z, the element that we took from C, because G is onto. Right? Again, also, now if you see, we took Y from B. This Y from B is actually from this B. Whether it is this B or this B, both are same. No? Both are same set B. If Y belongs to B, means that Y will belong to this set B also. Right? So also F is onto. Also F is onto. Therefore there exists. Therefore, since F is onto, and we have an element Y from B, which is this B, that is same as this B. So we have an element in this set, and since F is onto, if F is onto and if you have an element here, which is Y belonging to this set B, then there exists an element X in A such that F of X equal to Y, because F is onto. Because F is onto. So since also F is onto, which is given in the question, therefore there exists X belonging to the set A. So for every element here, you will find an element here such that F of this element will be equal to the element that we took from here, because F is onto. So also F is onto, therefore there exists an x belonging to A such that my f of x will be equal to the element that we took from B. The element that we took from B is y. So this is what we have. Right? So now what we have got, so we took an element z belonging to C from this set, which is same as this set. Then we found an element y in this set such that g of y is equal to C. And again for the element that we took from B, which is y, I go here, that element is here. Since f is onto, we will be able to find an x here such that f of x is equal to y. Now what we should prove that the element that we took from C, z belongs to C, we should find an x from the set A such that g of f of x should be equal to z. Now let's find what is g of f of x. What is g of f of x? What is g of f of x? Which means I should prove that I mean the x that we found from A, the x we took from A, g of f of that x is going to go to this z. We have to prove this. We have to show that here, which will show, which is easy to show, right? So what we will have here, g of f of x. Now what is g of f of x? That is g of f of x. And what is f of x? F of x is y. So I can say g of f of x is y. So instead of f of x, I'll put y. And what is g of y? G of y is what here? G of y is what? Z. Z. So what we have shown? We have shown that g of f of x is equal to z. So which means any z I took from this set C, we were able to find an x in this set A because x belongs to A. Right? We were able to find an x in this A such that g of f of x is equal to z. Therefore, it makes your g of f as onto. G of f is onto function. So we have proved that g of f is onto. Why we have proved? How we have proved g of f is onto? Because any element that we take from here, which is z, we were able to find an x belonging to A here such that g of f of x is equal to z. Therefore, g of f is onto function. Right? So this is a proof for this. So whenever your f and g are onto functions, your g of f function is also an onto function. And this is a proof for this. Right? So all of you can pause the video and take the notes. And I will stop the video here. You can watch my next video for the continuation of this. Thank you for watching. See you all in the next video. Thank you.